Welcome to Summarize Science. Today we are looking at a breakthrough in simulation technology called Elastica++. In nature and engineering, we often see soft, slender structures like the fibers in a bird's nest or the tiny cilia that move fluids in our bodies. These structures are historically very difficult to model because they bend, twist, and interact in incredibly complex ways. Researchers have developed this new framework to handle these physical challenges with incredible speed and accuracy. By using advanced computer programming techniques, this system can simulate up to 1 million individual filaments simultaneously. Compared to older methods, this framework achieves significant speedups across different types of computer processors. This allows scientists to study large-scale systems that were previously too expensive or slow to simulate. One practical application is the study of fibrous granular materials, which are essentially large, disordered packings of flexible rods. The team simulated over 1,500 stiff filaments to see how they behave when squeezed by a piston. This helps us understand how materials like bird nests or unwoven textiles gain their unique strength and flexibility. The research also explored active matter, where the individual rods are self-propelled, much like swimming bacteria. In these simulations, thousands of individual rods start to organize themselves into distinct patterns and groups over time. As the simulation progresses, the rods align and synchronize their movements, showing how order emerges from chaos. The framework successfully tracks how these populations distribute themselves based on their heading and position. Beyond just simple rods, this tool can be used to design and test complex magnetized robot assemblies. For example, researchers modeled magnetic cilia carpets that can move fluids using wave-like motions. They even created bio-inspired millipede robots that crawl across a surface when triggered by magnetic fields. The framework is also flexible enough to work with third-party software to simulate creatures swimming in water. This allowed for the study of a school of 32 fish-like swimmers interacting with a surrounding viscous fluid. By tracking the velocity and schooling properties, the researchers could see how the fish coordinate their movements. The results show a clear relationship between the spatial proximity of the swimmers and their overall behavior. Under the hood, all of this is based on the Coursera rod theory, which provides a mathematically exact way to describe 3D deformation. The system accounts for everything from bending and twisting to shearing and stretching. In recap, Elastica++ represents a massive leap in the ability to model the soft, flexible world around us. It provides a foundation for high-throughput studies of how complex systems move and interact. In the future, this could lead to more efficient medical microrobots or advanced materials that change shape on command. This open-source tool is now available for scientists everywhere to push the boundaries of soft robotics and biophysics. Thanks for watching Summarize Science, and stay tuned for more breakthroughs in the world of technology.